Hello, students. How are you all? So, I am your chemistry teacher, Mayur S. More. Welcomes you all on PW Amazing Platform. As you all know, this is PW English channel, and we are running Neet 50 Days Challenge batch for all of you, completely free. Right? So, today we're gonna take the very first lesson of our chemistry, that is some basic concepts of chemistry, right? So yeah, students are coming slowly. Yeah, no problem. So chalo, let's begin. Let me adjust. Yeah. So as you all know, so this is the very first chapter of chemistry. Yes, good morning, beta Rajeshwari. Neet World 365. Let's start. Prajiti Kumbham. Yes, beta. Very good morning to all of you. Okay. So chalo, let's begin. So as you all know, the very first chapter of chemistry, that is some basic concepts of chemistry, it has some topics which states nature and states of matter. You must already well aware with this, right? Nature and states of matter. After that, we're gonna see classification of matter. Now, classification of matter, which we had seen in the 9th and 10th standard as well, right? So we are not going to dive deep into it, okay? But the topic which is completely new to you, which you have not studied in 10th, is significant figures. Significant figures we're gonna see. And one more thing, every time Ram Sharan, yes, beta, maybe I'll be teaching the complete chemistry, but for the time being, Neet World, beta, my name is Mayur More. Okay? So today we're gonna start, as I told you earlier, the first chapter, that is some basic concepts of chemistry. Now here, what we are going to do, we are going to see the concepts shortly, and then we are going to solve the question based on that concept. Okay? Questions mostly will be of the PYQs, some previous year questions, okay, which will give us the better insight for the what type of questions generally been asked on the given topic. Okay, so significant figures. After that, we're gonna see laws of chemical combination, right? Laws of chemical combination, like what? Like law of conservation of mass, law of definite proportion, law of combining volume of gases, right? This is what, a law of multiple proportion as well. So these four comes under the laws of chemical combination. After that, we're gonna see atomic and molecular mass. You must already be aware with laws of atomic and molecular mass, how atomic mass is calculated, how molecular mass is calculated. After that, we're gonna see mole concept and molar mass, how mole concept and molar mass are correlated with each other. After that, we're gonna see percentage composition, that duration you will know, Mani Sampath beta, you will know the duration. Duration is around 3 hours. Okay, it's from 11 to 2 p.m. So after that, we're gonna see stoichiometry and limiting reagent. Stoichiometry and limiting reagent are one and the same topic only that we're gonna see. Okay, so chalo, let's begin. So first, nature and states of matter. Now, first of all, you tell me, what is matter? Can anyone answer this question? What is matter? Anything which has mass. Sir, take some water. Yes, beta, Ammu, I'll take water, no problem. But not now. Maybe after some time. Is this useful for JEE? Mani Sampath beta, it will be useful for JEE as well. Though this lecture is for the NEET, as you can see from the thumbnail, but yeah, it will be useful for your JEE preparation as well. Okay? Because anyways, we are going to learn the concepts and we are going to solve the questions, and we're going to learn how to solve particular question. And secondly, I am also going to start the poll here. Okay? Sir, I am going to be admitted to class 11. Have been waiting for 11 NEET batch in pure English. When will the batch be started? Tuhin beta, whenever the batch will be started, you will get a notification of it. Okay, you will get notification of it. You will come to know when the batch is going to start. Okay, but for the time being, let me start the chapter. So, matter. What is matter? Yes, someone has answered. Santosh Pitambare has answered. Anything that has mass. Yes, anything that has mass and occupies space is called as matter. हिंदी मीडियम से हूं, कहां से पढ़ूं, कहीं से भी पढ़ो बेटा, डजंट मैटर. ठीक है. सो anything that has mass, anything that has mass and occupies space, it's called as matter, as we all already know. ठीक है. Secondly, states of matter. What are some of the states of matter? You already know that matter has been classified mainly into three categories. One is solids, second one is liquids, and third one is gases. Now, what is the primary difference between solids, liquids, and gases? As you all know, in the solids, the constituent particles, they are compactly packed like this. The constituent particles are compactly packed in solids. Solids has very less intermolecular space. You can see here, solids has the least interparticle, I would rather say not intermolecular, interparticle space, least interparticle space. Liquids. Now, yes beta Santosh, that's the thing which we have learned in 9th and 10th standard as well. Solids has definite shape, volume and size. Solids has definite shape, size and volume that we already know. As far as liquids are concerned, in liquids, your particles, they are a little separated. In liquids, your particles are little separated. They have some space in them. They have some space in the liquid medium. So you can write here that interparticle distance is intermediate. Interparticle distance is intermediate, right? As far as liquids are concerned, liquid has definite volume, but they do not have a definite shape. Liquid occupies the shape of the container. As you all know, whatever your container is, liquid takes the shape of the container, but it do have a definite volume, right? Thirdly, gases. Now, what are gases? In gases do not have a definite shape, gases do not have a definite size, gases do not have a definite volume as well. So as far as gases are concerned, in gases, interparticle distance is very high, because your particles are separated by a huge distance. So basically, interparticle distance is highest. Interparticle distance is highest, right? Thirdly, the what I would say, the intermolecular energy. The energy of your particles is highest in gases. The energy of your particle is lowest in solids, and the energy of the constituent particles is intermediate as far as liquids are concerned. So that's how solid, liquid and gases are actually, they are differentiated, right? About this you must have studied already in your 9th as well as in your 10th. My screen is already been adjusted. Ali Sujata beta, my screen is already adjusted, that much you can see. Okay, so chalo, moving on to the next. So I hope you must be clear with this. Okay, chalo, moving ahead. Next, significant figures. Now, can anyone tell me what are significant figures? Let me take a sip of water. Yes, yes, yes. Now let's understand what are your significant figures. Round up the number. Yes, better Rajeshwari, you're right. So, significant figures. All zeros. All zeros are non-significant. All zeros are non-significant. Right? Firstly, for example, if you have a number called 291. So 291 has how many significant figures? 291 has significant figures 3, right? Similarly, if you have a number called 0.291. So in 0.291, this 0 is not a significant number. 291 is a significant number. So you are having 3 significant figures here. That's the first thing. Secondly, all these zeros, this is the first point. Second point, all zeros preceding to non-zero digit or digits are non-significant. So whatever zero you have coming before a non-zero digit would always be non-significant, which I just told you. For example, you can also have a digit like this, 0.02. So how many significant figure it has? So this 0 is preceding, or I would rather say this 0 is coming to the left hand side of a non-zero digit. 2 is a non-zero digit. This 0 is coming before a non-zero digit. So here number of significant figures would always be 1 only. That's the one thing. Thirdly, whenever you have zeros between two non-zero digits, whenever you have a 0 between two non-zero digits, that 0 would always be significant. So all the zeros situated in between two non-zero digits are always significant. For example, if you have a number called, suppose you have a number in 308. So 308 is a number. Now in 308, this 0 is coming, or this 0 is sandwiched between two non-zero digits. One is 3, another is 8. So that's why your 0 is what? Your 0 is coming in the significant figures here. So 3 is significant, as we all know. 8 is significant, but here 0 is also significant. Okay? Is this clear to you all? Okay, cool, fantastic. Yeah, fantastic, beta Priyanshi, Akash. Yeah, cool. Chalo, moving on to the last point. Now, all the zeros which are present on the right hand side of a non-zero digit are significant, provided those zeros are coming after a decimal point. Listen to me carefully. All zeros which are coming, or I would rather say all zeros which are placed to the right of non-zero digit are significant. provided they are coming after decimal point. They are coming after a decimal point. For example, 0.393. 0.393. First time understand chemistry this interesting manner. Best teacher of physics. I'm not physical chemistry. Okay, beta. Dhanyavad. So just look at this number 0.393. Now, oh sorry, I did not place 0 here. No, sorry, my bad. Suppose we are taking 0.390. Now look at here. This 0 is coming. This 0 is placed to the right hand side of a non-zero digit firstly. Secondly, it is to the right hand side of a decimal point. Here, this 0 is placed to the right hand side of your decimal point firstly, and secondly, before 0, non-zero digit is coming, and because of that, this 0 would always be a significant. That's why you have a 3. The number of significant figures are 3 only, and that is what all the rules of a significant figures are all about. Okay? Now, there was one question been asked on this very concept. We are going to solve that question now. Okay? So I hope all of you must have been clear with this, or I must have been able to revise the concept of significant figure. Okay? Now let's move to the question. Now what is the question? See, this question is given the numbers 161 centimeter, 0.161 centimeter, 0.0161 centimeter. The number of significant figures for the 3 numbers is. Now these 3 numbers are given. How many significant figures are possessed by each number here? Okay? And to be able to solve that question, I am going to get you some time. I am going to get you a 30 seconds for this. Okay? So go for this. Your time starts now. Ishan Thawari beta, this is the English channel. So I need to speak in English only. Okay? This is not Hindi channel. Had this been Hindi channel, I would have spoken in Hindi only. This is the English channel. Okay? Chalo. Cool. Fantastic. Time is up. Now let's solve this question, and then I'll come to the thing as well. How many people have answered it correctly? Okay. First of all, look at here. 161 centimeter. How many significant figure does this number has? This has 3 significant figures, right? As we all know. Look at the second number, 0.161 centimeter. Now after 0, after decimal point, all the numbers are non-zero. So basically this would also have a 3 significant figures. After that, you have a 0.0161. Now look at this number 0. This 0 first of all is coming to the right hand side of a decimal point, but this 0 is to the left hand side of a non-zero digit. Had this 0 been placed after this 1 or 6 or 1, it would have been counted as a significant. But this 0 is to the left hand side of a non-zero digit firstly, and secondly it is coming after a decimal point. That's why you cannot count this 0 in significant figures. But this 161 would be counted as a significant figure. So you have a 3 significant figures here, 3, 3 and 3. Basically all the 3 numbers has a 3 significant figures. So which options comes out to be correctly? This is wrong. This is also wrong. Yeah, 3, 3, 3. All the 3 digits has a 3 significant figures, and that is why Option D is the correct answer here. Now let's check out how many of you have answered it correctly. Option D is the correct answer. Let's see the result. 90% students have answered it correctly. Very good. Fantastic. Out of which 10 students have answered it correctly. Santosh, Neela, Rajeshwari, Priyanshi, Ishan, Akash, Ali, Sujata, Ragul, Tuhin, Kirti. Very good. Fantastic. And the student who have answered it firstly is Santosh Pitambari. Fantastic. Okay. Chalo. Very good, beta. Now let's move to the next concept. Then we go to the question as well. The concept is laws of chemical combination. Now there are different laws of chemical combination. The very first law that we are going to see is law of conservation of mass. Law of conservation of mass. Now what is the law of conservation of mass? It says that mass of all the reactants is always equal to mass of all the species present in products. Basically, whatever chemical reaction you are performing, the total weight of all the reactants is always equal to total weight of all the products. That is what the law of conservation of mass says. Now there is an exception to this law as well, but that exception doesn't come into the chemical reaction. That exception comes in the nuclear chemistry. Okay? But right now we are not studying nuclear chemistry. So simply law of conservation of mass says what? Total mass. You can take mass or weight, doesn't matter. Total mass of all the reactants is always equal to total mass of all the products. Total mass of all the reactants is always equal to total mass of all the products. Yes, beta Ishant, this is the concept of maybe class 9. Okay, but anyways, we need to see this. For example, suppose you have a reaction like this, where methane undergoes combustion with 2 moles of oxygen gas to get you CO2 plus 2H2O. Now you know this is reactant, these two are reactant and these two are products. Now let's take their mass and let's see whether this law is getting verified or not. So atomic mass of carbon is 12. Hydrogen is 1, but there are 4 hydrogen. So 1 into 4 plus 12, this is 16. Then oxygen, each oxygen has atomic mass of 16. You got total 4 oxygen atom. So this comes out to be how much? 64. So 16 plus 64, this comes out to be how much? This comes out to be 80. Now let's take 80 grams. Okay. Now go for CO2 and H2O. Now atomic mass of carbon again is 12. Again each oxygen comes out to be 16. The total mass here is 32 plus 12, 44. Molecular mass of water. Water's molecular mass is how much? 18. 2 into 18, it comes out to be 36. So 44 plus 36, how much it is? It again comes out to be 80 grams. So that's how law of conservation of mass is verified. Okay, clear everyone? Okay, cool, fantastic. Okay, now let's gonna see the next law, that is law of definite proportion. Just a second. Yes, I immediately have a question after that. Yes. Second, law of definite proportion. Law of definite proportion. Now, what is law of definite proportion, students? Can anyone tell me? See, every compound always has the same element by weight. Every compound always has the same element by same weight ratio, no matter what is the source of a given compound. So that means for example, you take the water. Okay, I'm gonna see in the exam, they are not going to ask you the statement. They are going to ask you whether the given compound or whether which law is being verified by the given reaction. That is what they are going to ask you. So let's take the example of water. Let's understand this through the water's case. Now, molecular mass of water is how much? Gram molecular mass of water is how much? 18 grams. Right? 18 gram is the molecular mass of water. Now, out of that 18, the 16 gram itself is possessed by what? Oxygen. Right? So, if we gonna find out the percentage of oxygen in H2O, percentage of oxygen in H2O is how much? 16 grams divided by 18 grams multiplied by 100. And this comes out to be 88.89%. This comes out to be 88.89%. Similarly, if you go on to find out the percentage of hydrogen in water, so there are two hydrogen atoms in water. Each hydrogen atom weighs 1 gram as far as gram atomic mass is concerned. So you gonna take 2 grams divided by 18 grams. Grams gets cancelled, multiplied by 100, and this comes out to be 11.11%. So, law of definite proportion states that water would always have oxygen as 88.89% in it, and it would always have a hydrogen as 11.11% in it, no matter what is the source of the water. You can fetch the water from the gutter, you can fetch the water from the river, well, lakes, ocean, streams, doesn't matter what sources you take the water from. Water would always have 88.89% by weight as oxygen and 11.11% by weight as hydrogen. Mayur, H3O1 plus is not water, beta. H3O1 plus is acidic species. When you put an acid into water, water accepts the H plus ion from the acid and then you get the H3O1 plus. So H3O1 plus is not a water. So that is what the law of definite proportion says. Clear? Is everyone clear with this? So every compound always has the same element with the same percentage by weight, no matter what is the source of the given compound. Okay, and this is applicable to each and every compound that you know. You can take ammonia, you can take methane, you can take ethane, or you can take no matter what you want. Okay, chalo, moving on to the next law. Law of multiple proportion. Law of multiple proportion. Now, what is the law of multiple proportion states? It states that when two elements combines to give you two or more compounds, when two elements combines to give you two or more compounds, then the weight of a one element, then listen to me carefully, then the weight of one element which combines with the fixed weight of the other, then the weight of one element which combines with the fixed weight of the other element bears a simple whole number ratio among them. Okay? Now this statement which I just stated might sound like a quite big statement and all that, okay, but as soon as I bring the illustration, it will get clear to you like a crystal clear. Okay? Immediately you will understand how we are going to illustrate it. Let's see now. Now let's look at here. Carbon combines with oxygen in two ways. Carbon and oxygen combines to get you two compound. One is carbon monoxide, another is carbon dioxide. Now if you look at here, the amount of carbon which has combined with O and amount of carbon which has combined with O2 is same. How much it is? Okay, let's write them besides like this. Now amount of carbon, secondly amount of oxygen. Look at here, amount of carbon reacted is 12 grams, amount of carbon here also reacted 12 grams. If you take the oxygens, amount of oxygen which has reacted here is 16 grams and here 32 grams. So as per the law, the different weight of one element, that is oxygen, when combines with fixed weight of the other element. What is the other element here? Other element is carbon, and the fixed weight is how much? 12 grams. So what are they saying is that between the 16 grams and 32 grams, there is a simple whole number ratio. And that is what is the law of multiple proportion says. So let's come down here. What is the ratio between 16 and 32? 16 as to 32. You might know the table of 16. 16 1 the 16, 16 2 is 32. So the ratio comes out to be 1 as to 2. Ratio comes out to be 1 as to 2. Right? Let's take another illustration. Suppose you have a sulfur. Suppose if you have a sulfur, sulfur combines with oxygen, SO2 to get you SO2, and the same amount of sulfur also reacts with O3 to get you SO3. Okay? Now if you look here, if you examine here, the amount of sulfur that is reacting is 32 grams in both the cases. But amount of oxygen that is reacting here you got 2 moles of oxygen atoms, here you got 3 moles of oxygen atom. 1 mole of oxygen atom weighs 16 grams. So 2, you are taking 32 grams in SO2 as to 48 grams in SO3. Right? So if you find out their ratio, 32 as to 48, you might quite well be aware with 16's table. 16 2 is 32, 16 3 is 48, right? So the ratio comes out to be 2 as to 3. Here ratio was coming out to be 1 as to 2. So this is simple whole number ratio. That is what the law of multiple proportion is all about. Okay? Is this clear to you? Okay, cool, fantastic. Okay, now let's see the next law, that is law of combining volume of gases. I guess this is the fourth law. law of combining volume of gases. Now what does this law says? Cool beta. So what does this law says? This law says whenever the gases are produced, whenever the gases are produced or gases are being reacting in a chemical reaction, they do so in a simple whole number ratio. They do so whenever the gases are being produced or gases are being reacting in a particular chemical reaction, they do so in a simple whole number ratio by volume, provided the reactions, provided they are being measured at same conditions of temperature and pressure. Now this law is quite controversial. There had been a lot of controversy around this law, because this law is kind of a corollary. This law is kind of a corollary of a Avogadro's law. We are going to see Avogadro law after this. Okay? So this is a corollary of that law. That's why later on this law has not been verified that much as Avogadro law was. But anyways, since we have come here, we're gonna see what this law is. So as I told you, whenever the gases are being produced or whenever the gases are reacting in a particular chemical reaction, they do so in a simple whole number ratio, provided they are being measured under the same conditions of temperature and pressure. Okay? There is no role of a catalyst here, Mayur. We are not studying the catalyst here. Okay? So look here. Suppose if you have 2 moles of hydrogen, which is a gas, reacting with 1 mole of oxygen, which is also gas, and this is getting you 2 moles of H2O. Imagine for a second that is also a gas. Now, if you have this water, so if you have this hydrogen as suppose 100 ml, now just look at the ratio. Just look at the ratio of their stoichiometries. When you have 2 moles of hydrogen, you are having 1 mole of oxygen. So if you are having 100 ml of hydrogen, then you are going to need a 50 ml of oxygen. Why? Look at the ratio between them, 2:1. So if this is 100, this has to be 50. If this is 200, this has to be 100. If this is 500, this has to be 250, and so on. Similarly, just observe the ratio between hydrogen and water. For hydrogen, you have taken 2 mole. For water also, you have taken 2 mole. Not we have taken, it is the normal stoichiometry of this reaction. So if this is the 100 ml, this has to be 100 ml only. Okay? Now, apart from this, you can take whatever amount you want. Suppose you are taking 2 liters of hydrogen. Sorry. So if you are taking 2 liters of hydrogen, you need 1 liter of oxygen, and it will produce a 1 liter of a water. That is what this law justifies. I can give you one more example here. Let's take the example of formation of ammonia in Haber's process. So here 1 mole of nitrogen reacts with 3 moles of a hydrogen gas, which gives us, now this is a reversible reaction, as you can see from this arrow. This is getting you 2 moles of ammonia gas. Now here also, suppose if you are starting with 100 ml of nitrogen gas, look at the stoichiometry ratio, 1:3. So if you take 100 ml of nitrogen, you're gonna need 300 ml of hydrogen gas. And similarly, just observe the ratio between number of moles of nitrogen, number of moles of ammonia. It is 1:2. So if this is 100 ml, this has to be 200 ml. You can make it like this as well. If you take this as 10 liter, you need hydrogen as 30 liters, which will produce 20 liters of ammonia gas. And that is what the law of combining volume of gases is all about. Okay? Is this clear with you? Okay, cool. Chalo, fantastic. Now to the last law, that is Avogadro's law. Now there are two Avogadro's law that we are going to see. We are going to see the Avogadro law of molar volumes as well, and we are also going to see the Avogadro laws of equal volumes. Now, what is the Avogadro's law of equal volume? It states that equal volumes of two or more gases, equal volumes of two or more gases contains, once say 2H2O X, sir, please. I'm not getting, Kirti, what are you saying, beta? I didn't understand. Once say 2H2O X, sir, please. 2H2O, this example? You want me to repeat this again? Have you not understood this? Okay, this example. Okay, cool. So look here. 2 moles of hydrogen are reacting with 1 mole of oxygen to get you 2 moles of H2O. Now here, if you take 100 ml of a hydrogen gas, you need a 50 ml of oxygen gas. Why so? It's because just look at the ratio here. The ratio is 2:1. You did not write anything before O2. That means the number there is 1. The ratio of their stoichiometry is 2:1. So if you take this as 100 ml, you have to take oxygen as 50 ml, and which is going to produce 100 ml of the water. Same case, if you have 2 liters of hydrogen, you need 1 liter of oxygen, and it will produce 2 liters of water gas. That is what this example suggests. Okay. Now let's see the last law, Avogadro's law. I hope this must have been clear with you now. So Avogadro law, what does it say? Equal volumes of all gases. So I written 1. Oh, sorry. My bad. Here you need to write 2 liters only. Yeah. Yes, beta. This is clear now. Yes. 2:1:2. So basically here, they were actually mentioning the ratio here. Look at the ratio. 2:1:2. Similarly here also, look at the ratio. 1:3:2. So this is what? This is a whole number ratio. This is the whole number ratio. 1:3:2, 2:1:2. Okay? And this ratio is always going to stay constant, no matter what, provided the conditions under which you are measuring their volume is constant in both the cases. Okay? Now look here. Equal volumes of all gases contains equal number of molecules. Now if you are having an equal number of molecules, that means you are also going to have an equal number of moles. You are also going to have an equal number of moles. So equal volumes of all gases contains equal number of molecules under the same conditions of temperature and pressure. Okay? So if you are having 2 or more gases, and if their volumes are equal, temperature and pressure is also equal, then all those gases would always contain equal number of molecules. That is what the Avogadro law is all about. Is this clear to you? Okay. There's one more law of Avogadro, which I am going to extend here. Avogadro's molar volume. Avogadro's molar volume. Now, what does Avogadro's molar volume states? It states that uh, under STP conditions, all the gases, under STP condition, the 1 mole of any gas would always contain the volume of 22.4 liters. So whatever gas you bring, doesn't matter whatever gas it is, how big, how small, doesn't matter. If the condition is STP, STP means standard temperature and pressure. What is standard temperature? Standard temperature is 0 degree Celsius, right? Yeah, 273 Kelvin. And standard pressure is 1 atm. So if the condition is STP, 1 mole of any gas in the world would always contain 22 liters of the volume. That is what the Avogadro's molar volume is all about. Under STP conditions, 1 mole of any gas, 1 mole of any gas always occupies the volume of 22.4 liters or decimeter cube, or you can make it 22,400 milliliter or centimeter cube. That is what Avogadro's molar volume is all about. Okay, cool. So I hope this must have been clear with you, and we are good to go to the questions based on this topic. See you again next week. MS Dhoni. But still I haven't. Give an example. Ali Sujata, beta, will solve this example. Will solve this topic. We're gonna take the question directly based on this. So through the question, you are going to understand it. Okay? Chalo then. Let's move ahead. Now let's look at the question here. What is the very first question? Equal masses. Pay attention to each and every detail which has been given in the question. Equal masses, I am saying equal masses of H2, O2 and methane have been taken in a container of volume V. Equal masses of H2, O2 and methane have been taken in a container of volume V at a temperature of 27 degrees Celsius in identical conditions. The ratio of the volume of gases H2, O2 and methane would be. Okay? Pay attention to these two things: identical conditions and equal masses. Okay? Now I am going to get you some time to solve this question. Okay? Since it's a bit complicated, I'm going to get you 45 seconds to solve this question. Your time starts now. Go for it. ठीक है, चलो टाइम इज अप. लेट्स सी. So, students, let's understand one thing. To solve this question, you need to know the Avogadro hypothesis. Now, what is, hello beta, Alam. So, what is Avogadro hypothesis? Avogadro's hypothesis. What does it states? Equal volumes of all gases would contain equal number of molecules. Now, equal number of molecules is like equal number of moles only. We just saw it couple of minutes ago, right? Equal volumes of all gases would contain equal number of moles. Now, how are we going to find out the number of moles for each species here? Let's take one by one. NH2. NH2 would be weight of a hydrogen gas divided by molecular mass of a hydrogen. What is the molecular mass of hydrogen? It has to be 2 only. It has to be 2 only, right? Number of moles of oxygen. Number of moles of oxygen would be weight of the oxygen divided by molecular mass of oxygen. What is the molecular mass of oxygen? 32. Right? Lastly, number of moles of methane. For that, we need to take the weight of a methane, WCH4, that divided by molecular mass of methane. What is the molecular mass of methane? It's a 16 grams, right? So they have asked us the ratio of volumes of gases H2, O2 and methane. Now what that would be? You need to take the ratio of number of moles only, because ratio of number of moles is nothing but the ratio of number of volume only. You can see here, right? So we are going to take WH2 divided by 2, which because they have taken hydrogen first, then they have taken oxygen, WO2 of oxygen, and WCH4 by 16. Now you know how maths works, right? We are going to multiply each one of them by the largest number here. What is the largest number? 32, right? So you are going to take 32 by 2, here 32 by 32, and here 32 by 16. And this comes out to be 32 by 2 is 16, 32 by 32 is 1, 32 by 16 is 2. So the ratio comes out to be 16 as to 1 as to 2. And therefore, correct answer is 16 as to 1 as to 2. So option C is the correct answer here. That's how you can solve this. 16 as to 1 as to 2. Clear? So basically what they have taken is Avogadro hypothesis only, which says that equal volumes of all gases would always contain equal number of moles. So what is the formula for number of moles? This is the formula for number of moles. They have asked us to calculate the ratio of their volume. Now since the ratio of volume and ratio of number of moles is same as per the Avogadro hypothesis, that's why I took the ratio of number of moles. And that's what we end up with the answer, 16 as to 1 as to 2. So let's see how many of you have answered it correctly. Oh my God, none of you have answered it correctly. Not only, all of you have answered it A only, and A is wrong. So that's why this is wrong. Okay, doesn't matter, that's okay, it's fine. Chalo, moving on to the next question. What volume of oxygen gas O2? What volume of oxygen gas O2 measured at 0 degrees Celsius and 1 atm is needed to burn completely 1 liter of a propane gas C3H8 measured under the same conditions. Okay? So basically they are asking us what is the volume of oxygen gas measured at 0 degrees Celsius and 1 atmospheric pressure, which is 1 atm, which is STP. So what is the volume of oxygen gas measured at STP is needed to burn completely 1 liter of a propane gas, whose volume is also measured under the same conditions. Okay? To be able to solve this question, I am going to get you 45 seconds. Your time starts now. Okay, chalo, cool. Just a second, okay. Okay, chalo, all right. Let's solve this question now. Now, what are they asking us? They are asking us. They are asking us to write. They are asking us to write the combustion reaction of propane. Now let's take the propane first. This is where your propane is, C3H8. Now I am going to get you a simple trick. I am going to get you a simple trick which would be able to make you solve any question of this sort. For example, if you have C3H8 here, okay, later on I am going to get you, first of all we're going to solve this question, then I'm going to get you a trick for to solve this question. Okay, now I don't know how much oxygen do I need here. Okay, but the trick here, look at the trick. How many carbon atoms are here? 3 carbon atoms are there. So all the 3 carbon atoms are going to get you CO2. What are they going to get you? Whatever carbon atom you have present in your hydrocarbon, all of them are going to get converted into carbon dioxide. So it is going to get you carbon dioxide. And just look at here, how many hydrogen atoms do we have? 8 hydrogen atoms. All the hydrogen atoms that you have are going to get converted into water molecule. So it is going to get you a 4H2O. Now just look at here, how many oxygen atoms are there on the right hand side? You got 3 into 2, 6. 6 plus 4, 10. Basically you got 10 oxygen atom, right? So you are going to have a 5O2 here. And now we are going to, do you remember the Gay-Lussac's law? Gay-Lussac's law of combining volume of gases? Yes. That is what we are going to apply here. We are going to take the volume of all the gases here. Now let's write their volume. This is 1 liter. As you can see, the stoichiometry that C3H8 has is 1. The stoichiometry that O2 has is what? 5. So this is 5 liter. The stoichiometry that CO2 has is 3. So this is going to be 3 liter. The stoichiometry that H2O has is 4 liters. So this is going to be 4 liter. That's it. So what they have asked us? What volume of oxygen gas is needed? So it is right in front of you. 5 liters of oxygen is needed, right? So correct answer is option A, 5 liters. That's it. Now let's understand how can we solve this question if it comes for some another hydrocarbon. For example, if it comes for the methane, let's see how can we write this question. CH4. Now, as I told you, whatever carbon you have present in your hydrocarbon, Array, Mayur, I am going to tell you about the pole. Wait for a minute. So all the carbon is going to get you CO2. And all the hydrogen that you have here, 4 hydrogen, since each water molecule has 2 hydrogen, 4 hydrogen would be converted into 2H2O. Okay? So 2 into 2, how much? 4. You got a 4 oxygen atom there. So you need a 2O2. Now you can again convert this into liters. How can you convert this into liter? The stoichiometry for methane is 1. So it is going to be 1 liter. Stoichiometry for oxygen is 2. So it is going to be 2 liter. Stoichiometry for CO2 again is 1. So it's again going to be 1 liter. Stoichiometry for water is 2. So it is going to be 2 liters. So that's how you can solve such type of a question. Okay? As far as this question is concerned, option A is the correct answer. Only 12.5% people have answered it correctly, and only Mayur has answered it correctly. None of you have answered it correctly except for the Mayur. Okay? Chalo, very good, fantastic. Neela is right on top. Mayur is somewhere here. Okay? No problem, doesn't matter. Okay? Chalo, let's move to the next question. And Mayur, why are you spamming by writing English, Hindi, Marathi? This is the English channel. I hope you know that. This is Physics Wala English. Hello sir, how are you? I am good, beta Soham. I hope you'll also be good. So this is Physics Wala English. This is not a Hindi channel. When I teach in PW Maharashtra, that's where I can speak in Hindi or in Marathi. This is the English channel. I need to speak in English only. Okay? Because there are many students who don't understand Hindi. And those students comes here. Okay? Thank you, sir. I appreciate your efforts. Yeah, thank you. Chalo then, let's move to the next question. Now, what is this question? The molecular weight of O2 and SO2 are 32 and 64 respectively. The molecular weight of O2 and SO2 are 32 and 64 respectively at 15 degrees Celsius and 150 mm of mercury, 150 millimeters of mercury pressure. 1 liter of O2 contains n molecules. 1 liter of O2 contains n molecules. The number of molecules in 2 liters of SO2. Now please pay attention to this part. 1 liter of O2 contains n molecules. The number of molecules in 2 liters of SO2 under the same conditions of temperature and pressure will be. Again, pay attention here. Same conditions of temperature and pressure. Okay? To be able to solve this question, I am going to get you. Again, Rohit Gupta, you are great, sir. So good lecture. And your pronunciation is superb. Okay, beta. Thank you. Pronunciation is not important here, since the questions are not going to be audible to you, right? You are going to read them and you are going to solve them. So that is the most important part, I suppose. And you should understand how you can solve the question as fast as possible, which would make you be able to solve high score in your NEET exam. Okay? Okay, cool. So, to be able to solve this question, I am going to get you 45 seconds. Give your try and solve this question. Your time starts now. सर मैंने कुछ नहीं पढ़ा पूरे साल, क्या मैं अभी से स्टार्ट कर सकता हूँ? It's difficult now. You can start the one day before the exam as well. Okay? But it's not going to get you pass or qualify for the exam. Sir, how to prepare for NEET from class 11th? I'm in class 10th right now. Beta Lija Bastin, start from the very first chapter, and whatever is being taught to you daily, make sure you finish that topic on that day itself. ठीक है सर? आप एमएडी3 बोर्ड्स बैच में थे ना? आई एम देयर एज वेल, आई एम हियर एज वेल. ठीक है, तो चलो, द टाइम इज अप. लेट्स गो फॉर दिस क्वेश्चन. So 1 liter of O2, 1 liter of O2, it contains how many molecules? It contains n molecules. Now I told you to pay attention to the conditions. ठीक है? If the conditions are same, then the volume of 2 or more gases are going to contain the same number of molecules. ठीक है? So if you are having 1 liter of O2, it contains n molecules, and if you are having 1 liter of SO2, it would also contains n molecules. Why? Because what have this said is that same conditions, look here, same conditions of temperature and pressure. Conditions for temperature and pressure are exactly same. So if you have not just O2 or SO2, you can take any gas that you want. You can take H2, you can take helium gas, you can take SO3 gas, you can take CO2 gas, you can take NO2 gas, you can take NO3 gas, whatever gas you want. If their temperature and pressure is same and volume is also same, then they would contain same number of molecules. That is what the Avogadro law says, right? Hello beta, Neeta Chavan, hello. So, but they have not asked us to take the 1 liter for SO2. They have asked us to take 2 liters of SO2. You can see here. So under the same conditions where 1 liter of O2 contains n molecules, 1 liter of SO2 would contain n molecules. Then 2 liters of SO2 would contain how many molecules? It is going to contain 2n molecules, right? Straightforward and easy. Clear? And that's why correct answer is option C, 2n. 2 liters of SO2 going to contain 2n molecules in it. And that is why option C is the correct answer. How many of you have answered it correctly? Oh, cool. 100% of you have answered it correctly. But how much is the 100%? Yeah. So 8 students have answered it and all of them got it right. Cool. Santosh, UC Durgesh, Sachi Chaudhary, Rohit Gupta, Kirti, Tuhin, Akash, Prasun Datta. Cool. So Santosh Pitambare has ranked up. Tuhin has ranked up second. Kirti third. Akash fourth. Chalo, good. Fantastic. Neela, Rajeshwari, Ishant, Ali Sujata. These students have just joined. But go, very good. You cracked it. I liked it. Okay. Chalo then. Moving ahead to the next question. Now this question is kind of a stoichiometry based question. Okay? It is kind of a stoichiometry based question. So I'm going to put this into that category. But this type of question can also comes under the category of Gay-Lussac's law of volumes. Okay? What is the question? What is the weight of oxygen? What is the weight of oxygen required for complete combustion of 2.8 kilogram of ethylene. If you are having 2.8 kilogram of ethylene, and if it is undergoing complete combustion in presence of oxygen, then what is the weight of oxygen that is going to be required for this? And to solve this question, I am going to get you, let's take 45 seconds. Your time starts now. ठीक है, चलो cool. Let me take the sip of water now. So, ethylene, right? Now for ethylene, you must know the formula of ethylene. It is C2H4. C2H4 again is going to react with oxygen. Now in ethylene, how many moles, how many carbon atoms do we have? You already have 2 carbon atoms. So 2 carbon atoms are going to get you 2 moles of carbon dioxide plus 4 hydrogens are going to get you 2H2O. Right? So just look at how many oxygen atoms do we need here. 2 into 2, 4. 4 plus 2, 6. So basically you are going to need 3 moles of oxygen atoms there. Right? Now we are going to convert this. Now we are going to convert this into what? Their molecular mass. Let's write here. Molecular mass. How much, what is the molecular mass of C2H4? Carbons, hello beta, Choti Kumari, hello. What is the atomic mass of carbon? 12. 12 into 2, 24. 24 plus 4, 28 grams. So this is 28 grams, right? And you are going to need 3 liters of oxygen for this. How much? 3 liters of oxygen. So can I write 3 liter as 3 kg? Just a minute. Chetan Garg, happy Mahashivratri. Yes, happy Mahashivratri. So you are having 6 oxygen atoms here, right? The atomic mass of one oxygen atom is how much? 16. You got 6 oxygen atoms. 16 into 6. How much it is? 96 grams. Right? Now 28 grams of ethylene requires 96 grams of oxygen. Then 2.8 kg of ethylene requires how much of oxygen? It is that straightforward. So 2.8 kg requires X grams of oxygen, right? Cross multiply. Cross multiply. 28 grams multiplied by x grams is equal to 2.8 kg. Let's convert this 2.8 kg into grams. So 2.8 into 10, 1 kg is how much? 1 kg is 10 raised to 3 grams. Multiplied by 96 grams. Now let's make it x grams. 2.8, let's make it 28 into 10 raised to 2 grams multiplied by 96 grams divided by 28 grams. So grams gets cancelled. 28 ones are 28. So 96 into 10 raised to 2. 96 into 10 raised to 2 grams. Let's convert this into kilogram. So if you bring the decimal on the left hand side, it becomes 9.6 into 10 raised to 3 grams. And 10 raised to 3 grams is how much? 10 raised to 3 grams is 1 kg. So this comes out to be 9.6 kg. And that says why. Correct answer is option C, 9.6 kg. ठीक है? Clear? So let's see how many of you got it right. Option C is the correct answer. 90% people have answered it correctly. Very good. Fantastic. Santosh, Akash, Sachi, Tuhin, Mayur, Ragul, Durgesh, Shubh, Kirti. This many people have got it correctly. And on the leaderboard, Santosh Pitambar is right on top. Akash has ranked up to claim the spot. Second, Tuhin, third number. Chalo, very good. Fantastic. Let's move ahead to the atomic and molecular mass concept. Now you must already be aware with what is atomic mass and molecular mass. I'm not gonna beat around the bush to teach this concept because you must have already studied this, and I'm expecting you to revise it alongside me. Okay? So what is atomic mass? The weight of any atom, relative to the weight of 12C carbon isotope. The weight of any atom relative to the weight of 12C carbon isotope is called as atomic mass. So for example, if you want to measure the weight of single oxygen atom, what are you going to do? You are going to take the weight of single oxygen atom, and you are going to divide this by 1/12 weight of C12 carbon isotope. C12 carbon isotope. And sir, you look like Rajnikant. Am I? You are the first one who is telling me this, that I am looking like Rajnikant. I heard people saying me, I speak like a Rohit Sharma. I sound like him. That I have heard. But Rajnikant? Anyways. So, this comes out to be 16 AMU. I hope you already know what AMU is. AMU is atomic mass unit. So weight of a single oxygen atom is 16 AMU. Now many of you, hello beta Nidhi, hello Ashok. Yes beta Praveen, Nagabadullah, you're right beta. atomic mass unit. Now many of you might be puzzled, sir, here we have written 16 AMU, but while solving the question we take the 16 grams, right? So when I take a 16 grams, it's a gram atomic mass. That means weight of an atom expressed in grams is gram atomic mass. And first of all, why do we take the 16 grams also? Let's understand that. So this is 16 AMU. It is the absolute weight. Hello beta Vikku. It is the absolute weight of a single oxygen atom. But if you take the 1 mole of oxygen atom, weight of a single atom is actually doubling the atomic number of that given atom. Na sir. Praveen beta, it depends. हाँ बेटा विक्कू, थोड़ा सा मुझे थोड़ा सा खांसी हो रहा है, लेकिन ठीक है. तो यस बेटा प्रवीण, that is not always the case. That is not always the case. For example, if you take the fluorine, the atomic mass of fluorine is 19 AMU, but the atomic number of fluorine is how much? Atomic number of fluorine is 9. So it is not always the case. It depends how many neutrons are present in your atom. If the number of neutrons present in your atom are exactly same as the number of protons in it, then it can be applicable what you have said. But otherwise, it is not always the case. Okay? So this is what the weight of a single oxygen atom. But if you have, yes beta Kirti, I took the water. But if you have the 1 mole of oxygen atom, if you have 1 mole of oxygen atom, 1 mole of oxygen atom weighs, so 1 mole of oxygen atom means how much? Avogadro number of oxygen atoms, right? 6.022 into 10 raised to 23 number of oxygen atoms. Now that multiplied by 16 AMU. What is the AMU? AMU, if you take that weight in grams, how much it is? If you take the AMU in grams, how much it is? It comes out to be 10 raised to minus 24. 10 raised to minus 24 grams. So 16 AMU. So let's convert this 6.022 into 10 raised to 23 into 16 AMU. AMU is 1.67 something multiplied by 10 raised to minus 24 grams. Okay? And if you multiply all of them, it comes out to be 16 grams. And that's how you take the gram atomic mass of oxygen as 16. So this is gram atomic mass. That is what you write as GAM. That is what you write as GAM, gram atomic mass. Now same thing is applicable for the gram molecular mass as well. Same thing is applicable to gram molecular mass as well, right? You know how the molecular mass works. For example, if you have a molecule like glucose, C6H12O6, that's a glucose molecule. So if you want to measure, if we take any other number, shall we get the same number? No. I'm not getting it. Anyways, so if you want to measure the molecular mass of glucose, what are you supposed to do? We need to take the atomic mass of each and every atom present in it. You need to sum it up and then you get the molecular mass of a given molecule. So you got a 6 carbon here. Each carbon weighs 12 hydrogen atom, each hydrogen weighs 1. 6 oxygen atom, each oxygen atom weighs 16. And this comes out to be how much? this comes out to be 180 AMU, and if it's in grams, gram molecular mass, it comes out to be 180 grams. So that's how the atomic and molecular mass are being measured. And there's a one more thing. there are some elements for which we need to take the average atomic mass. For example, isotope, your boron. Boron has two isotopes. Boron has two isotopes. Boron 10, boron 11. Similarly, chlorine. Chlorine also has two isotopes. Chlorine 17 is the atomic number, but atomic mass is 35 and atomic mass is 37. Okay. Now you also need to know their percentage abundance. The percentage abundance of chlorine 35 is around 70%, and for chlorine 37 is around 30%. So this is their abundance. So you cannot take straightforward the atomic mass of chlorine as 35. Here you need to take the average. You need to take the average of atomic mass. So average atomic mass, the formula for that is what? Formula for atomic mass is mass number multiplied by percentage abundance. 1 plus mass number multiplied by percentage abundance. Second, divided by not total abundance, divided by 100 always. 70 plus 30. So divided by 100 always. Here at the denominator you are always going to have 100. Okay? So mass number is how much? 35. Abundance is 70. So 70 into 35. There mass number 37. Abundance is 30 divided by 70 plus 30. 70 plus 30 is how much? It comes out to be 100. Right? Now let's solve this. 35 multiplied by 0 is 35. 35 7 is how much? 35 200 245. And 37 into 30. 37 into 0 is 0. 37 into 3. 37 into 3. 111 110 divided by 100. Now this comes out to be how much? 2450 1110 0 5 plus 1 6 4 plus 1 5 2 plus 1 3. So this comes out to be 3560 divided by 100, which comes out to be 35.6, and that is the average atomic mass of your chlorine. So you cannot take directly 35, you cannot take 37. For our convenience, we take 35.5. It is actually 35.6, but for our convenience, we take 35.5 to make the calculation easier. So that's how the average atomic mass thing actually works. Okay? So I hope this must have been clear with you. Now we will head into the questions. Okay? Chalo then. So the very first question, an element X has the following isotopic composition. Element X has 200 mass number has 90% abundance, 199 has 8% abundance, and 202 mass number has 2% abundance. Okay, so the weighted average atomic mass of the naturally occurring element X, the weighted average atomic mass of naturally occurring element X is closest to. Now you are going to, you need to solve this question the way we just have solved. Okay, so I'm going to get you a complete 1 minute for solving this. Your time starts now. ठीक है, चलो, time is up. Now let's solve this question. So average atomic mass of element called X is going to be what? So look at its atomic mass 200. 200 is going to get multiplied by its percentage abundance. How much it is? 90 plus 199 is going to get multiplied by its percentage abundance, which is 8, plus 202, which is going to get multiplied by 2%. Now that divided by 90 plus 8 plus 2, which is always comes out to be 100. Sir, we have X as 90% abundance. No, why can't we take simply 200 as the answer, sir? No, we cannot take. You cannot take because it is not equally distributed, Kirti beta. Had this been equally distributed, no. Had this percentage abundance been equally distributed, then you can directly take the average. This is a statistical tool to solve such question. Okay? So 200 into 90, 90, 0, 0. 90 into 2, 180. So 18,000. Yeah. 199 into 8. So it is 200 into 8. How much it is? 1600. 1600 is getting subtracted by 8. 1592. Plus this is 404 divided by 100. So this comes out to be 18,000, 1592, 404. 4 plus 2, 6, 9, 5 plus 4, 9, 8 plus 1, 9, 1. So this comes out to be 19,996 divided by 100, which comes out to be 199.96. It comes out to be 199.96. So yeah, you can take 200, no problem beta. It comes out to be 200 only, because 199.96 is nearly 200 AMU only. Okay, so it comes out to be 200 only, no matter, but you need to confirm that. You need to confirm that by solving it. Okay, that's why correct answer is option D, AMU. 200 AMU, option D is the correct answer. So 87.5 sorry percent people have answered it correctly. Very good. संतोष पीतांबरे, आकाश, राहुल, यूसी, कीर्ति, तुहिन, महक. And on the leaderboard, संतोष पीतांबरे is right on top. आकाश, तुहिन, कीर्ति, दुर्गेश, राहुल. ठीक है, चलो, very good, fantastic. Now, if you have solved this question, you would also be able to solve the next question, which is similar. This question is similar like the earlier question, but I am going to get you this question as your homework. Okay, you can take this question as HW. I hope you all know the meaning of HW, right? HW is homework. So you can take this as a homework and you can solve this question. Okay, by using the same method which we have used. Chalo, to the next concept, that is mole concept. But before we could go there, just a sec. Have I taken this? Yes. Mole concept and molar mass. Now, I am going to explain you the Y map here. Here, I am going to explain you the Y map. I hope you all know the meaning of Y map. What is Y map? Let's understand here. So at the center of this Y, you are going to have a number of moles. At the center here, you are going to have a number of moles. And how do we find out the number of moles? There are many ways by which you can find out the number of moles. See, now what are those methods that we're gonna need? So, amount of substance, whatever amount of substance you have taken, that is divided by atomic mass or molecular mass. Any substance that you know, if its amount of substance is given, you can just divide it by its atomic mass or molecular mass. What do we supposed to get? We get a number of moles. That is the one way of getting the number of moles. There's a one more way by which you can get the number of moles. What is that? That is number of species which is being given. Number of species. Now, number of species means what? Number of species could be number of atoms, number of molecules, or number of ions. It could be anything. I'll explain that as well. So, number of species into bracket, number of atoms, ions, or molecules. Number of atoms, ions, or molecules. That is the number of species, and that is divided by Na. What is Na? Na is Avogadro number. Na is Avogadro number. So this is the one way by which you can get the number of moles. And the lastly, the volume of a gas divided by 22.4 liters. Now whatever volume your gas is being given, it could be in the liters or decimeter cube, or it could be in the milliliter or centimeter cube as well. So basically volume of a gas, and remember this situation is applicable only for the gas firstly, and secondly at STP. Volume of a gas divided by 22.4 liters or decimeter cube, or 22,400 milliliter or centimeter cube, and this is all at STP conditions. And that is what the Y map is all about. Sorry. That's how you can actually solve the mole concept wala thing. Okay? Is this clear to you all? Yes, cool, clear. Okay then. Chalo, fantastic. If this is clear with you, let's move to the next question. Now, which one of the following has maximum number of atoms? This type of question has been asked so many times in the exam, in the different exams: CED exam, Neet exam, JE exam, Karnataka CED exam, and EM CED exam. So many exams this question has been asked. Not exactly this, but this type of a question. So which species of this has the maximum number of atoms? Okay. Now to be able to solve this question, I'm going to get you 45 seconds. Your time starts now. Will I get marks if I write only option number of MCQ in answer and don't write the statement in front of the class in 10 CBSE English board exam? No, you don't get. You won't get the marks. You are in the 10th exam. 10th exam is supposed to be subjective, right? For the objective questions, yeah, you can write. Chalo, anyways. So now here, How can we solve this question? Now, to be able to solve such question, you need to see one thing. Sir, JEE advanced के questions करिए. Aditya beta, this is, I guess this batch is supposed to be for the NEET, right? So if this batch is supposed to be for the NEET, how can I take the JEE advanced question? I can take the questions of JEE mains, but I cannot take the questions of JEE advanced. There is no point in doing that. That syllabus is not for the NEET. Okay, so now just look at here. Any atom which has maximum number of moles would also have maximum number of atoms, right? Maximum number of atoms would be present in any species which contains maximum number of moles. Any species which contains maximum number of moles would contain maximum number of atoms. It is that straightforward, right? And what is the formula for number of moles? Weight of a substance, whatever substance they have given you, weight of that substance divided by atomic or molecular mass. Okay. Now you can clearly see here the number of moles and atomic or molecular mass are inversely proportional. They are inversely related. Now look at this question. 1 gram of silver, 1 gram of magnesium, 1 gram of oxygen, 1 gram of lithium. That means in all the 4 cases, amount of substance given is exactly same. If the amount of substance given is exactly same, what is the factor which is going to decide the number of molecules present in them? Number of atoms present in them. The factor which is going to decide here is the number of is their atomic or molecular mass, because you can see here, if you take all of them, here you will have 1 divided by 108. 1 is what? Amount of substance of silver, its atomic mass is 108. Here 1 divided by 24. Here 1 gram of oxygen, 1 divided by 16 multiplied by 2. You might say, so why did I put 2 there? I put 2 there because 1 oxygen molecule would contain 2 oxygen atoms, right? And this is the atomic mass of oxygen, 16. That is why. Or you can directly tell, oh yeah, I had made it perfectly only. And lithium, 1 by 7. So if you solve 1 by 108 is going to be the smallest number. Here you are going to get 1 by 8. And here you are going to get 1 by 7. So out of all these species, 1 by 7 would be the biggest number. So if the 1 by 7 is the biggest number, it is obvious that it would contain the highest number of molecules, because it is going to contain the highest number of moles. And that is why option D is the correct answer here. Okay? So option D, 50% students have answered it correctly. Akash and Santosh Pitambare. Okay? Chalo, very good. Santosh Pitambare is right on top. Very good. Fantastic. Okay? Chalo. Now we're going to take only 1 or 2 questions of this category. And then we're going to head on to the next topic. Okay? Because I'm not feeling so well. So I need to take question of each and every topic there. And we are running by time, right? So next, simple question. In which case the number of molecules of water is maximum? In which case number of molecules of water is maximum? Question is quite simple. I'm going to get you 45 seconds. Do solve it. Your time starts now. ठीक है, चलो, time is up. How can we solve this? It's a very simple thing. More the number of moles, more will be the number of molecules present in the given species. That's how it is, right? So for water, we know that density of water is 1. So 18 ml of water is also 18 grams of water, right? So for number of moles here, 18 divided by 18, which comes out to be 1 only. 0.8 gram of water, 0.18 divided by 18, that would be 0.01 moles. 0.0224 liters of water vapors at 1 atm and 273 Kelvin, that is STP condition. So this is 22.4 liters. 22.4 into 10 raised to minus 4 divided by 22.4, which comes out to be 10 raised to minus 4 moles, right? And lastly, 10 raised to minus 3 mole. Here they have already given 10 raised to minus 3 mole. So just look at and screen all the questions and see where are we getting maximum number of moles. We are getting maximum number of moles in option A. So it should contain the highest number of molecules of water. And that is why option A is the correct answer here. How many of you have answered it correctly? Let's see. 100% people have answered it correctly. Fantastic. Akash, Durgesh, Santosh, Push, Kirti, all, Meet, Ragul, Mehak. All of you have answered it correctly. Very good. Fantastic. Okay, chalo then. Moving ahead to the next part. Now, as I told you, we're gonna head to the next topic because this is consuming so much time. I want to cover each and every topic of this chapter before we could end this session. Okay, chalo then. This is done. Next, percentage composition. Now, how does percentage composition works? And it's very, very simple. When I told you, when we saw the statement, what statement did we see? We see the statement of law of definite proportion. Remember? So in the law of definite proportion, what did I take? I took the percentage of oxygen or hydrogen present in the water. Now, same thing goes here as well. In percentage composition, there are two ways by which we can do the percentage composition. There are many experiments which helps you to find out the percentage composition, but I'm going to get you a simple example. So tell me the duration of the session. You see, Durgesh, duration of the session is for 3 hours, 11 to 2 p.m. Okay, but I'm not feeling that well, so I'll take as much as I can sustain. What is universal gas constant? That is R beta. R is universal gas constant. Okay, chalo. So percentage composition, let's take the example of sulfuric acid. Now in sulfuric acid, what is the percentage of sulfur? If you take the molecular mass of sulfuric acid, it comes out to be 98. 98 is the molecular mass of sulfuric acid. So if you want to find out the percentage of sulfur in it, the percentage of sulfur in it would be 32 by 98 into 100. Percentage of oxygen would be 64 divided by 98 into 100, right? So you can solve this. Percentage of hydrogen would be 2 divided by 98 into 100. So this is the way by which you can find out the percentage composition. And there's one more category of percentage composition where we are going to find out the empirical. Okay, thank you, beta. So there's one more way by which you can find out the empirical formula or molecular formula of a given compound. Now here they are already going to provide you the percentage composition of a given compound. Okay, For example, carbon is 30%, oxygen is 25%, hydrogen is 13%, like that. And from that, you need to find out the empirical formula of that given compound or molecular formula of that compound. First of all, you need to understand the types of formula. So there are two types of formula. I can tell you that empirical formula, and second is molecular formula. Empirical formula and molecular formula. So what is empirical formula? Empirical formula is the simplest ratio of number of atoms present in a given molecule. Empirical formula, it is the simplest ratio of number of atoms present in a given molecule or a compound. Molecular formula, it is the actual ratio of number of atoms present in a given molecule. Molecular formula is, it is the actual ratio of number of atoms present in a given molecule or a compound. Sir, I am in class 9, my final exams are over. I have completed my class 11 syllabus. I am doing chemistry from you. Oh, Naru official. You are quite advanced, beta. That's very good. So, let's take the example of benzene here. Now, we know that benzene has the molecular formula C6H6. The molecular formula of benzene is C6H6 and its molecular mass is how much? Its molecular mass is 78. Okay. Now here the actual ratio of number of carbon and hydrogen atom is, I'll write here the ratio as well. The actual ratio of number of carbon and hydrogen atom is 6 carbon as to 6 hydrogen. The ratio comes out to be 6 as to 6, which is 1 as to 1. But 1 as to 1 I am not going to write here. The ratio is 6 as to 6 only. The 1 as to 1 ratio I am going to write in empirical formula, because the ratio of two atoms is 6 as to 6. But if you simplified it, it is going to be what? It is going to be 1 as to 1. So 1 as to 1 is the empirical formula ratio. 6 as to 6 is the molecular formula ratio. Now 1 as to 1 means 1 carbon and 1 hydrogen. So basically empirical formula of benzene is CHN, where this N is going to be equal to 6. So this is the empirical formula of your benzene ring, CH bracket N. Now if you put the N6 here, you are going to get CH6, which comes out to be C6H6, and that is the molecular formula of a benzene. So that's how molecular formula and empirical formula are exactly correlated. In the reaction, if the concentration of reactant A is triple, the rate of reaction becomes 27 times. What is the order of the reaction? Concentration of reactant A is triple, the rate of reaction becomes 27 times. The order of the reaction is 3 beta. Order of the reaction is 3. Okay? But we are not solving the chemical kinetics here. Naru official, the answer for your question is order of the reaction comes out to be 3. Okay? But here we are solving mole concept. When we'll come to chemical kinetics, we'll see that time. Okay? So ratio N is going to be equal to what? N is going to be equal to be 6 here. So now I'm going to tell you one more thing here. The molecular formula is always equal to N into empirical formula. And you can see that here. Molecular formula is C6H6, empirical formula is CH, and N is equal to what? N is equal to 6. That's it, right? Similarly, molecular weight. I'm not going to give you a break push. I'm going to finish the session itself. Okay? Because my capacity is also getting drowned. So molecular weight is also N into empirical formula weight. Now just look at here. Molecular weight of benzene is 78 and empirical formula weight is 13. So say 78 n into 13, and that's how your n comes out to be 6. Okay. Now let's solve question based on this. I hope this must have been clear with you all. Okay. Now look here. An organic compound contains 78% by weight of carbon. An organic compound contains 78% by weight of carbon and remaining percentage of hydrogen atom. The right option for the empirical formula of this compound is. Okay. And to solve this question, I am going to get you quite some time. Just a second. Yes, I am going to get you 45 seconds to solve this question. You can go for it. The concentrated sulfuric acid that is peddled commercially 95% of weight. Density, array beta. We're gonna solve that type of question in solutions. Okay. Thank you, beta, Rohan. We are going to solve that type of question in solutions, beta, not here. Okay. So here, let's the student focus on this concept. Okay, so I guess this much time is enough. Time is up, वैसे भी. So let's see how can we solve this question. Okay, now see, carbon is 78% by weight and hydrogen is remaining. So let's suppose 100 grams of compound, 100 grams of compound is present. 100 grams of compound is present. Now it contains 78% of carbon. That means it contains 78 grams of carbon, right? And remaining means 22% of hydrogen. So when you take 100% as 100 grams, the 22% becomes 22 grams of hydrogen, right? So now, how can we solve this question? So first of all, whatever amount of substance that they have given, just divide that by their respective atomic mass. This is the first step. This is carbon, hydrogen. So 78 divided by 12. How much it is? 12 6 the 72. So this comes out to be 6.5. This comes out to be 6.5, And hydrogen, how much it is? 22. 22 divided by 1. It comes out to be 22 only, right? After this, take the smallest number of this and find out the simplest ratio. After this, you need to find out the simplest ratio. And to solve simplest ratio, what do we need to take? We need to take 6.5, which is the smallest number, and divide every number by that. So 6.5 divided by 6.5, 22 divided by 6.5. So 6.5 divided by 6.5 comes out to be 1, and 6.22 divided by 6.5. This comes out to be nearly 3. This comes out to be nearly 3. So basically you got 1 carbon and 3 hydrogen. You can see here 1 carbon and 3 hydrogen. 1 carbon and 3 hydrogen, and that's why its empirical formula comes out to be CH3. CH3 is the empirical formula for this, and that is why option D is the correct answer here. ठीक है, clear है? So option D is the correct answer. Each one of you have answered it A. That is absolutely wrong. That is not the right. ठीक है? Anyways, no problem. Let's move on to the next question. There is same question of this category, but I'm going to put, sir, how can I use this time? Didn't listen chemistry lecture. How can I use this time? I didn't get you. Why divided by 6.5, sir? Because it is the smallest number, beta. It is the smallest number. You need to divide by smallest number in an order to find out the simplest ratio of the atoms. That is why every time from this you take the smallest number and divide each and every number by that smallest number so that you can get the exact ratio. Okay? Anyways, chalo. So this next is for a homework. Do solve this question at home. This is for your homework. Okay? And now we are moving to the last topic of today's session, that is stoichiometry and limiting reagent. I'm going to explain both the concepts in the stoichiometry itself. Let's understand how does stoichiometry works. So let's take the example of tea making. Suppose you are making a tea at home, and I don't know how you people make the tea at home, but as far as my example is concerned, I can tell you how do I make a tea. So suppose I have to make a tea for 3 people. So for 3 people, I'm going to make a 3 cup of tea. So for 3 cup of tea, I keep 3 cup of water for heating. Okay. Then I grate some ginger. I put the grated ginger into it. For 3 cup of tea, I usually use 4.5 teaspoon of sugar, right, which I put into it. Then I let it boil. Once it has boiled, then I put 3 teaspoon of tea powder. So for 1 cup of tea, I am going to need 1.5 teaspoon of sugar, 1 teaspoon of tea powder, right? And at the very end, when this solution has been boiled, then I pour some water, then I pour some milk into it. Okay? So as soon as I put some milk into it, I let it boil, let it heat for some time, then I filtered it out. Now let's take this ratio. For 1 cup of tea, I need 1.5 teaspoon of tea, 1 teaspoon of tea powder, and half cup of milk. Now this is the ratio. Now this is the stoichiometry, right? Now suppose on a one fine day, the guest arrived at my house. Now there are 6 guests overall, so I need to prepare 6 cups of a tea, right? But I have lots of water with me. I have kgs of sugar stored in the storeroom. I have lots of milk as well, but I do not have enough tea powder. So I went on to make a tea. I took the not exactly six, but okay, I took the 6 cups of water. I let it boil. I grated. I put some grated ginger into it. I put 9 teaspoons of sugar into it. Then I went on to check the tea powder. I had only 4 teaspoons of tea powder. Now you tell me, if I have 4 teaspoons of tea powder, I can make only 4 cups of tea. I cannot make 6 cups of tea, right? Obviously, I'll make a 4 cups of tea and I'll distribute among the 6 people. That's for the obvious reason, right? But I'm not saying that here. I'm saying look at this from the chemistry's perspective. So but anyways, even if you have 4 teaspoons of tea powder, you can make only 4 cups of tea only. So you cannot make a 6 cups of tea. So here your tea powder is the limiting reagent, because your tea powder is deciding how much tea you can make. So that is what is called as limiting reagent, and that's how the stoichiometry actually works. Now let me put the very simple example. Okay, now let's understand this from the very simple reaction. Methane, we know that if you take the methane, it undergoes combustion reaction with oxygen to get you CO2 plus 2H2O, right? Now here you always need a 2 moles of oxygen. Here you always need 2 moles of oxygen, right? Now let's put number of moles of each species. Okay, let's understand it from the perspective of number of moles and atomic mass as well. Okay, not atomic mass, molecular mass. Number of moles for methane is 1, oxygen is 2, CO2 is 1, and water is also 2, right? So if you have a 1 mole of methane, you need a 2 mole of oxygen, then you can get 1 mole of CO2 and 2 mole of H2O. Now let's take this into the amount of substance way. Okay, so you can see here methane is how much? 16 grams. Oxygen, how much oxygen do we need here? 64 grams of oxygen we need here. That gets you 44 grams of CO2 and 36 grams of water, right? This is what the ratio is all about. So suppose if you are performing this reaction in another way, and if you are having 16 grams of methane, you are having 16 grams of methane, right? But the oxygen that you need here, which is 64 grams, you you don't have that much oxygen. You have only 32 grams of oxygen. Then the question is, how much grams of CO2 can you obtain from here? And how much grams of water also you can obtain from here? The question is very, very simple. Whenever such type of question comes, always fall back to the original reaction. What is the original reaction? This is the original reaction. And in original reaction, if you take a 16 grams of methane, you need a 64 grams of oxygen. That is 4 times of the oxygen as much, which gives you 44 grams of CO2 and 36 grams of water. Now, here you are having the same amount of methane. You are having 16, you need a 16 grams of methane. You do have a 16 grams of methane. But The oxygen that you need here is 64 grams. But how much oxygen do we have here? 32 grams. That means in this case, your oxygen is going to be what? LR. LR means what? Limiting reagent. So now your oxygen is the one which is going to decide the amount of product that is going to form. The same way when you have a 4 teaspoon of tea powder only, that time only 4 cups of tea was able to form, right? But if you are having large amount of tea powder, you can make as much tea as you want, right? But if you have less amount of tea powder, you cannot make much tea. So similarly, 16 grams of methane is present, but oxygen is how much? 32 grams. Now you again need to fall back to the original reaction. In the original reaction, when you took a 64 grams of oxygen, it gave you 44 grams of CO2. Now you have a 32 grams of O2. How much CO2 can you obtain? If the amount of oxygen has been halved, then the amount of CO2 would also be halved. It would be how much? It would be 22 grams. Similarly, when you had a 64 grams of O2, you are getting 36 grams of water. So amount of O2 has been halved from 64 to 32. Then the amount of water which is getting formed is also going to get halved from 36 to 18. Like this. Now you can just add them together. Let's see. 32 plus 16 is 48. And 22 plus 18 is what? 40. So you are saying, sir, why this is this discrepancy? There is no discrepancy actually. So when 64 grams of oxygen was there, 16 grams of methane was completely reacting. But here you are having only 32 grams of oxygen. So if 64 grams of oxygen required 16 grams of methane, then the 32 grams of oxygen would require only half of the methane. That means it is going to need only 8 grams of methane. And remaining 8 grams of methane would be excess. Remaining 8 grams of methane would be excess. So 32 plus 8, 40. 22 plus 18 is 14. So basically you are left with 8 grams of excess of methane. That's how this limiting reagent and stoichiometry concept works. Manisha Sharma, I cannot tell you that whether Udan is best for you or not. You can decide that for yourself, beta. I cannot tell you. But if you ask me, it is obviously I'm gonna suggest you to go for it only. ठीक है? So I hope this must have been clear with you, right? So let's go for the last question, or we'll solve some questions. Let's see how many questions I can sustain. Okay. For the time being, this is going to be the last question, and this question is based on the limiting reagent concept. This question is based on the limiting reagent concept. Okay. Let's see. The number of moles of hydrogen molecules required to produce 20 moles of ammonia through Haber's process. The number of moles of hydrogen molecules required to produce 20 moles of ammonia through Haber's process is. Okay? To solve this question, I'm going to get you 45 seconds. Your time starts now. Yes, beta Manisha Sharma. Why just 97? You can score 100% by using Udan batch, beta. But you need to study by yourself as well. You need to take the guide from the mentors, obviously. Okay? So, let's solve this question. Haber's process. Now, for to be able to solve this question, you should know what is Haber's process. So, in the Haber's process, 1 mole of nitrogen reacts with 3 moles of hydrogen to get you 2 moles of ammonia. So this is the stoichiometry first of all. 1 mole of nitrogen reacts with 3 moles of hydrogen to get you 2 moles of ammonia gas. Okay? So what have they asked us? 20 moles of ammonia. Now you can see here, if you take 1 mole of nitrogen, 3 moles of hydrogen and 2 moles of ammonia would be produced. If you want to produce 20 moles of ammonia, you need a 30 moles of hydrogen and 10 moles of nitrogen. Straightforward. So correct answer is 30 moles of hydrogen gas is required. Straightforward. So option D is the correct answer here. 100% people have answered it correctly. Very good. 6 students have answered it. Fantastic. Santosh, Akash, Durgesh, Kirti, Chandu और मंदू नहीं महक. ठीक है. Santosh Pitambar is right on top. Akash is on second. Kirti is on third. Very good. Fantastic. Let's see the next question now. Now this next question is again on the basis of concept of limiting reagent. What is it? When 22 liters of 22.4 liters of hydrogen is mixed with 11.2 liters of Cl2, each at STP, the moles of HCl formed is equal to. Okay? Question is quite easy. Again, I am going to get you 45 seconds. Go for it and tell me what could be your answer. Hi Shakib Raza. ठीक है बेटा, time is up. Let's see. First of all, you should know how can you solve this question first. You should know the original equation for this reaction. Original equation for this reaction is 2H2 gas plus Cl2 gas, which gets me 2HCl gas. 2H2 plus Cl2 gas gets me 2HCl gas. This is what the real equation is all about. Okay? So you can see here, beta, if you have a, let's take the mole ratio, number of moles. So if you have a 2 moles of hydrogen, you need a 1 mole of Cl2 to be able to produce 2 moles of HCl, right? Now, conditions are at STP. You can see here, conditions are at STP and not balanced. No, sir, it is balanced, beta. Ah ha 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 ha. 2HCl. Sorry. Not 2H2. Sorry. My bad. It is H2. It is H2 only. So 1 mole of H2, 1 mole of Cl2 gets you 2 moles of HCl. Now conditions are being given at STP. That means whatever volume they have given for the, even for the hydrogen or for the chlorine, we gonna convert that directly into what? Into number of moles. So hydrogen is 22.4 liters. As you all know, 22.4 liters divided by 22.4 liters comes out to be 1 mole. So number of mole for hydrogen, what is given is number of moles 1 only. Now look at the chlorine. For chlorine it is 11.2. 11.2 divided by 22.4, that comes out to be 0.5. Number of moles is 0.5. So this comes out to be 0.5. Now you tell me, what is the limiting reagent here? What is the limiting reagent? For 1 mole of hydrogen, you need a 1 mole of chlorine. But for 1 mole of hydrogen, we are having only half mole of chlorine. So that means, yes, beta Chandu, you're right. That means chlorine is the limiting reagent here. If chlorine is the limiting reagent, it is the chlorine which decides the amount of product that is going to form here. So 1 mole of chlorine gets us 2 moles of HCl. Therefore, half mole of chlorine would get us 1 mole of HCl. And that is why correct answer is going to be 1 mole of HCl. So option A is the correct answer here. And let's see how many of you got it correctly. 75% of you have got it correctly. Very good. Akash, Durgesh, Santosh, Kirti, Mehak, Paush. Akash is ranked up. Akash has climbed to the top spot. Santosh has been downgraded to the second spot. Kirti is on third as usual. So Manisha Sharma, you are saying sorry sir because I directly asked question without saying you good afternoon and saying pranam. No, it's okay beta. Manisha, it's okay. I don't mind these things. Okay? And chalo. Last question. Now this is honestly the last question. Okay, I told you that question is the last, but I went on to take 2 more questions. But I want you to get completely clear with this limiting reagent concepts. That's why I thought to take 1 more question, and this is literally the last question. So question is, in the reaction 4 moles of ammonia reacts with 5 moles of O2 to get us 4 moles of NO and 6 moles of H2O. So this is the original reaction. Okay, when 1 mole of ammonia, when 1 mole of ammonia and 1 mole of O2 are made to react to completion, then what will happen out of this 4? Out of this 4, what will happen? Okay, and to solve this question, I'm again going to get you 45 seconds. The time starts now. Chalo. Sir, I answered firstly, but in the poll I will come at the fourth or fifth. Because there must be someone who is answering before you, beta. Okay. So now look here. For 4 moles of ammonia, you can see here, I'm going to write the number of moles ratio here itself. For 4 moles of ammonia, you are going to need 5 moles of oxygen. And then it is going to get you 4 moles of NO and 6 moles of water molecule. Right? That is what is the complete thing. Right? Now what are they saying is that when 1 mole of ammonia reacts with 1 mole of oxygen, and if they react to completion, then what will happen out of this? Now clearly you can see here, for 4 moles of ammonia you need a 5 moles of oxygen. That means you need slightly more oxygen. So if you have 1 mole of ammonia, you need 1 mole of oxygen, that's for sure. In fact, you need more of the oxygen. For 1 mole of methane, or we can solve this. We can solve this for the mole ratio. Mole ratio. Number of moles of oxygen divided by number of moles of ammonia. Right? In the original reaction. In the original reaction, number of moles of oxygen are 5. Number of moles of methane are how many? 4. So 5 divided by 4. It comes out to be 1.25. Right? This is original. Now in given NO2 divided by NH3. Given number of moles of oxygen is 1 and number of moles of methane is also, ammonia is also 1. So the ratio has to be 1.25. That means in the given equation, we are having less amount of oxygen. So if the amount of oxygen is less, that means oxygen is your LR. That means oxygen is your limiting reagent. And if the oxygen is the limiting reagent, it is the oxygen which is going to get consumed completely. And that is why all the oxygen will be consumed. This is the correct answer. All the oxygen will be consumed. Ammonia would be left behind. That's why option A is the correct answer. 37.5% people have answered it correctly. Very good. Of which Akash, Santosh and Pawosh have got it rightly. Let's see on the leaderboard. Akash is right on top. On second number you got Santosh. On third number you got Kirti. And that's it for this particular session. I really enjoyed with all of you. In the next session, we are going to see the next chapter. Okay? So let's meet then. Till then, bye-bye and take care. Keep studying. Keep solving all the questions. Okay? Thank you. Bye-bye, guys. Yes, beta Manisha, you're right. Correct answer is first A only. Yes, Akash, thank you, beta. Let's meet in the next session with the next chapter. Yes, beta Kirti, thank you. Bye-bye.